Good morning dear students. Welcome to my YouTube channel. Today we are going to solve question number 3 and 4 of exercise 11.2. In last lecture we have seen how to draw a tangent on a circle and what is the difference between tangent, secant and all that properties related to tangent I told you, right? So let's start with the third one. Here draw a circle of radius 3 centimeter. Take 2 points P and Q on one of its extended diameter, each at the distance of 7 centimeter from its center. Draw tangents to the circle from these 2 points P and Q. I am going to give you a rough idea how to draw a construction, okay, without using rounder and scale. Just rough construction I am going to show you, so it is better you to get idea from it, okay. So then we will do by using rounder and scale. So here they are asking that with a 3 centimeter circle, O is a center, AB is a diameter, and from both extend from center, any point P and Q are taken like this at both extreme of diameter, okay, which is 7 centimeter away from center. 7 centimeter away from center. And from these two exterior points P and Q, we have to draw a tangents like this. Are you getting it? Okay. So now actual construction we are going to do. Let's start. Now as it asks to take a 3 centimeter diameter, radius for and draw the circle. So first of all, by using scale and rounder, we have to take a distance a 3 centimeter, okay, or radius 3 centimeter, and with center O or any alphabet you can take to denote the center and draw a circle, okay. Here I take O as a center, and here I am showing that the diameter, which is the largest chord passing from the center. Now they are asking to take a point on both the extreme of diameter such that the distance is 7 centimeter each from the center. So I have to take a 7 centimeter, put 0 here at the center and mark at a 7 centimeter. So now I denote this point as a Q, and again from 7 centimeter from center to another point, another extreme. So here again it is 7 centimeter. So this is P. So now the distance OP is equal to OQ is equal to 7 centimeter. Is it clear? Now next thing is to draw a tangent from P and Q on this circle. Okay, as I told you, from each exterior point, 2 tangents we can able to draw on a circle. So here are 2 external points. So 2 tangents from P and 2 tangents from Q we are going to draw. Okay, so first of all, to draw a tangent, what we have to do? We have to draw a perpendicular bisector of OP and OQ. Okay, so I am showing you again. Take a more than half of OP, draw arc on upper side, downward side from P and O. Similarly, as OP and OQ are same radius you can maintain as it is and draw arc upper side and lower side by taking a center O and Q. Now intersection point of arc you have to join to, so we get a midpoint of OP and OQ. Now I am joining this intersection points of arc. Now this intersection point, when we draw a line, it will intersect at OP, that is M, and if it intersect at OQ, I am giving name midpoint as a N. So in short, N is a midpoint of OQ and M is a midpoint of OP. Now as usual, what we used to do, take a center point as a center or midpoint as a center, either take NQ or ON as a radius and draw a circle which intersect the original circle at two distinct points, and that two distinct points are the point of contact. So let's see how to do. As a center N, NQ or ON as a radius, right? Now draw a circle again like this. So these two distinct points, have you seen? So this circle, the new circle intersect the new original circle, older one, at two distinct points, and we give name RS. So these R and S are points of contact. Okay, and if we draw a line from Q to R and Q to S, it will make a two different tangent. Are you getting me? Similar thing you have to apply here. As a center M with radius PM or MO, you can draw a circle like this which intersect the original circle at two different points. Okay, you see these points? Okay, so these are the two distinct points which are called as a point of contact. So I am giving name here T and here it is V. So if I pass a line from P to T and P to V, these two are again different tangents which are passing through external point P. Okay, so let's join the points and draw a tangent. Is it clear? So like this you can draw if they are asking the external points are to extent of the diameter of this much length from the center and all that, and they are asking to draw a tangent, then you can follow these steps, so you will get the construction. Is it clear? Can I repeat the steps again? So first step is draw the radius of 3 centimeter. Second step, take OQ, OP is 7 centimeters such that they are extent of a diameter. Third step, draw a perpendicular bisector of OP and OQ, which will give a midpoint of M and N respectively. Next point is with center M, radius OM or PM, draw a circle which intersect the earlier circle or original circle in two distinct points. Now join the points to make a tangent. Similarly in case of Q, with center N and radius ON and NQ, draw a circle which intersect the original circle in two distinct points R and S. Join QR and QS to get the tangents. And if they are asking more one question and they are asking to find out the measure of tangent, then you can just put here your scale and find out how much it's have a length. Is it clear? Like that you can draw the or construct the tangents from exterior points. Okay, now let's see the justification. Now let's see the justification. In justification, join OT. This is the center O of original circle and this is the point of contact. So first join OT such that angle OTP, here it is angle OTP is equal to 90 degree. See, one thing I want to tell you, that as we know that any tangent subtended with the radius of the circle is always 90. Okay, but in justification we should not write it, because in what is the justification? In justification we have to prove that we have construct tangents. Okay, so here as angle OTP is a 90, the reason behind 90 we have to mention is it is a semicircle. It is a semicircle and any angle subtended in semicircle is 90 degree. Remember this thing. Is it clear? Okay. Now PT, as it is 90 degree, it means PT is perpendicular to OT. If it is perpendicular, it means PT is a tangent. Similarly, PV, join PV first and PV is perpendicular to OV, as OVP is a 90 degree again. Why 90 degree? Because angle subtended in a semicircle and therefore OV perpendicular to PV or PV perpendicular to OV and therefore PV is a tangent. Now first half is completed. Now come to the second half. Now join QR such that angle ORQ or QRO is 90 degree. Again, the reason behind this 90 degree is semicircle. The angle subtended at semicircle is 90 degree. Similarly, as OR here and QR is there, they are subtended at 90 degree. Therefore, QR is perpendicular to OR and therefore QR is a tangent. Similarly, in case of QS, as QSO is 90 degree because the angle subtended in a semicircle and therefore QS is perpendicular to OS and therefore QS is a tangent. Like that you have to give justification. Is it clear? Use your logic when you represent or write the justification. Okay, so let's do the next question 4. Now let's start the question 4. Draw a pair of a tangent to a circle of a radius 5 cm which are inclined to each other at an angle of 60 degree. Very important question of construction chapter. Okay, so how to draw inclined angle 60 between the tangent. Okay, so for that we have to do a rough diagram. I am going to show you first. So they are what asking? They are asking that if this is the circle, if exterior point is there, okay, and if these are the tangents like this, okay, this is the center, the radius, okay. So this inclined angle between the tangents, these are RS, just give name, PR and PS are the tangents. So the angle between the tangents, it's called inclined angle between the tangents, that they require 60 degree, that they require 60 degree. So how to draw or how to construct 60 degree here? As you see, ORPS is a quadrilateral. Okay, it is a quadrilateral. Then what is the sum property or sum property of angle of quadrilateral? The sum of all the angle of quadrilateral is 360, isn't it? Okay. Now, as you see, and as I told you earlier, that the angle between the radius of the circle and the tangent, it is 90 degree. So, these two are 90 degree. Okay. If these two are 90 degree, and as we know, angle O plus R plus S plus P is equal to 60 degree. And out of this we want 60. S is 90, R is 90, and O that we don't know. Okay. So this 90 plus 90, 180. 180 plus 60. It is 240. Okay. And therefore, the total, here it is total 360. And this is equal to 360. And therefore, angle O is equal to 360 minus 240 is equal to 120. Like that we have to do calculation. Angle required here. How to calculate? You got it? Like this, we can calculate the angle at the centered, by which we can do the construction and we can get our final answer. Is it clear? I repeat again. As you see, this is ORPS is a quadrilateral. The sum of angles in quadrilateral is 360, and therefore angle OR, angle P, angle S is equal to 360. Out of this 4 angle, we have a value of P which is 60, which they ask to construct. R and S as the property of tangent, it is 90 degree with the radius. Okay, so both are 90. So 90 plus 90, 180. 180 plus 60 is 140. So 240. So 360 minus 240 is 120. Is it clear? So here we have to construct a 120 degree. Now, instead of 60, if they ask about 75 angle, to construct the inclined angle between the tangents, 75. So, same calculation you have? No, the calculation change. Why? As the angle change, the total calculation will be changed. But the main funda is this. Main concept is this. The sum property of angle in quadrilateral is 360 and these two are 90 degree. As this change, the angle of center and angle inclined at the center will also change. Is it clear? Okay. Like this we can do. Now let's see the actual construction by using rounder and scale. Now let's start construction 4. So as they ask, we have to first take a center O or any name, and with radius 5, we have to draw a circle. So like this, you can take a radius of 5 centimeter, okay, by using scale and rounder, and then you first draw a circle with 5 centimeter. Is it clear? Now, draw a radius, any one radius like this. Give name OA as a radius. As you know, we need here how much angle? 120. Here 90 we need. It means at both sides we have to construct angle here at angle A, at point A 90, and at O 120. So first step is to construct a 90 degree at angle A. So first of all, take any arbitrary radius you can take, arbitrary radius, and then take an arc like this. So from inside, the first arc gives you angle 60, second arc gives you 120. If you join A and this arc, This is 120. This is 60. But we need 90. Without changing the radius, if we want 90, we have to take exactly half of 60 and 90. Is it clear? You have already done or studied in earlier classes how to construct angle 90, 45. Okay. So you must have knowledge about that. And therefore, if we pass a line from this point A through this intersection point, then it will create a 90 degree at point A. So like this. Is it clear? So this angle is 90 degree. Now, what is the next step to do? To construct 120 degree at center O. So how to construct? Again, take any arbitrary radius, take a center O and draw an arc like this. Draw arc, okay, from inside. First arc is 60. Second arc is 120. So if we join O to this point, first it is a 60. O to this point, this is 120. So we got angle O is 120. Now pass a line from this intersection point through this intersection point from O. Okay, so now this is the another radius. This another radius, let's give name B. And as it is a radius, we want to draw a tangent. Again, we have to create here 90 degree. So for this construction, you have to construct a 3 time angles. First, second and third. This is 90. This is 120. Now again 90. So again same procedure. Take any arbitrary radius as a center at a center B. Make a arc from inside 60. Again from 60. Again one arc will give you a 120. We want how much? We want 90 degree. So between 60 and 120, that is a 90 degree. So like that. Now pass the line through this and from point B. So it will create a 90 degree here, and if you give point R here, okay, so now this is inclined angle between the tangent is 60 degree. Isn't it interesting? Okay, like this you can construct. So here AR, BR are tangents. They ask the inclined angle is of 60 degree, and here it is. Is it clear? Okay, now let's see the justification. Let's see the justification in a quadrilateral OARB. Here, OARB. Using angle sum property, we have angle O, which is 120, angle A 90, angle B 90, and angle ARB is equal to 360. All these four angles, if we do the sum of them, we get 360. Why? Because OARB is a quadrilateral. Okay, and therefore if we do addition of all this, we got 300. So 300 plus ARB is equal to 360, and that's why we can say that angle ARB is 60 degree. Like that you can give a justification. So how to write down the steps? First of all, first step is draw a circle of 5 centimeter radius. Second step, join OA and make a radius OA. Create angle A is equal to 90 degree. Create angle O is equal to 120 degree. Create angle B 90 degree. So OB is equal, OB is a second radius. Okay, OB is another radius. At B, create angle 90 degree. Now join the tangents together and give a point R here. Okay. Now like this we got ARB is 60 degree. Now instead of 60, if in exam it is asked the inclined angle is 75, they want, then what should you do? At angle O, how to calculate this? This is 90 plus 90, this is 75, okay, and as you know the opposite angles in a quadrilateral, they are supplementary, so it is 180. So out of 180, 75 is this. So how much it is? 105. Like this you have to use your knowledge, okay, and then you can construct the same with the same steps. That's it. Okay. Now we are going to stop our lecture here. We will meet you soon with the question 5 and 6. Till then, goodbye.